Hello, in this video we are going to solve rational equations algebraically, and we're only going to focus on ratios. This topic will get a little bit harder in difficulty for the following lesson. Our objective is students will be able to solve rational equations algebraically. I want to remind you that a rational equation is an equation that involves at least one rational expression, meaning we have a variable in at least one denominator. Rational equations can have extraneous solutions, and remember that these extraneous solutions are solutions, aka answers, right, that we plug in, and these solutions, they are just excluded values that we do not include because excluded values, they make the denominator a zero. And remember, we cannot divide by a zero. So here are steps for solving a rational equation. The first thing that we're going to do is we're going to utilize what we learned yesterday in class, and that's finding the lowest common denominator. Remember that we need to make sure our rational equation is factored. We'll find our shared factors. We'll find our remaining factors, and that's our LCD. Once we have our LCD, we'll multiply every term by the LCD to clear the denominators. That's our goal. Get rid of your denominators. Once we have that, we can easily solve the resulting equation. Last but not least, we need to check for extraneous solutions. So the easy way to do this is to right off the bat to note your excluded values. So I can't even maybe put that in as step 0. Identify excluded values. Okay, and then step 5, state your final solution set. So here's our first example. We have 5 over 6 is equal to negative 13 over 12x. So I'm going to go ahead and go with my own advice. Step 0, we're going to identify excluded values. Excluded values. And in this case, our excluded values, looking at our denominator, the 12x, this produces an excluded value of x equals 0. What this means is if our solution is 0, we have to throw it out, cannot include it. Step 1, we're going to identify our LCD. Now, a lot of people, or students I should say, you guys struggle with identifying your LCD when it's just numbers like this. And what you want to do is you want to look at your lowest value and say, okay, can I represent 12x as 6? And we definitely can, right? So I'm going to rewrite this as 5 over 6 is equal to negative 13 over 6 times 2x. And I'm going to take one of each, right? So here I have a shared factor, right? That's shared, 6, and then our remaining factors are 2 and x, right? 2 and x. So therefore our LCD is 6 times 2 times x, which is 12x. No biggie. Okay, so LCD 12x. Remember, the whole reason that we do this is in step 2, so we can go ahead now multiply by the LCD. Okay, so when I do this, when I go ahead and multiply 5, 6 and negative 13 over 12x, when I multiply this by 12x, and when I multiply this by 12x, this cancels with this. On this side, the 6 reduces this 12 to 2, and we can rewrite this problem as 10x is equal to negative 13. Now, you should ask yourself here, did all the denominators disappear? And if the answer is yes, you did your job right. If the answer is no, you picked the wrong LCD. Okay, your LCD has to be big enough to reduce or to completely destroy, annihilate, get rid of all of your denominators. Okay, the whole goal is to have something nice and pretty like this. 10x equals 13 and negative 13. And here's step 3. Step 3 is to solve, and I'll write this in purple. So over here, I'm going to divide this by 10, divide this by 10, and we get x is equal to negative 1.3. No calculator needed because I'm a smart cookie. So x equals negative 1.3. That's step 4. That's step 3. Step 4 is to check for extraneous solutions. Okay, and you do this by saying, okay, is negative 1.3, does that match any of my excluded values up here? I compare step 0 and step 3, and the answer is no, there are no excluded values. And step 5 will say our final solution is x is equal to negative 1.3. All right. I hope you enjoyed that video on solving rational equations algebraically. That is our step process, kind of our concept and our skill for solving this equation and solving rational equations algebraically. Please give this a thumbs up, subscribe, watch the next video. I'll do one more example like this, and then a couple binomial examples. Hello and welcome to this video on solving rational equations algebraically. This is the second video on this topic, and this is the second example. If you missed the first video, go back and check it out on solving rational equations. So for this example, we're asked to solve the equation and to check our solution. So the first thing that we need to do right away is we need to identify excluded values. And this occurs, these values will produce a 0 in our denominator. Since I have 6 times x, if x is 0, then that will make my denominator 0. So 0 is an excluded value. Additionally, the same thing here. What we really have here is 9 over 2 times x times x. I just expanded this out. Instead of exponential form, I just expanded it out. And this will also help us with our LCD as well. Okay. So we're going to go ahead, and the next thing that we need to do is we need to identify lowest common denominator, and we do this. We identify which factors are shared, so which ones appear more than once. Okay, so which ones are shared, and that would be an x. So I have one x that's taken up. Now here's a common question. What about that second x? Well, that is remaining. I have an extra one here, so I need to include this, and you'll see why here in a moment. I'll make sure this is apparent. And then I have a 2, and I have a 6, right? So if we're trying to identify our lowest common denominator, it's 2 times 6, which is 12, and then I have 2 x's. So 12x squared is our lowest common denominator. The next thing that we're going to go ahead and do is we are going to multiply each term by the LCD. So I'm going to take 9 times 2x squared and negative 5 times 6x, and I'm going to multiply this side by 12x. I'm going to multiply this side by 12x squared. Okay, and again, in the first video I talked about this. What should happen is that this should cancel, right? X squareds cancel, top and bottom. Here my 2 cancels, and this becomes a 6. So I have 6 times 9, so this gives me 54. Over here, x cancels here with one of these x's, so I'm just going to cross out my 2, becomes x to the first, and then this 6 cancels with this 12 to give me 2. So all I did was I just multiplied, I reduced, and again what should happen, you'll notice the denominators disappear. On this side, the only thing left standing is negative 5 times 2 times x. So this is negative 10x. Do not forget about this. This is common error. Even if this is what you have to do, if you have to cancel this whole thing and rewrite 2x to the first, then go ahead and do that. And I actually recommend that. A lot of times I've seen that happen. So don't forget that x. Okay, so I have 54 is equal to negative 10x. We have to go ahead and here we have to solve. So I'm going to divide this side by negative 10, divide this side by negative 10, and we get negative 5.4 is equal to x, which gives us x is equal to negative 5.4. Okay. So what we also have to do, we just need to go ahead and check our solution. Is this an excluded value? And our excluded values up here were 0. So the answer is no. That's our final solution here. All right. So I hope you enjoyed this example. Please like my video, subscribe, and check out the next ones on binomials. Hello and welcome to this video on solving rational equations algebraically. This is the third video. So for this example here, I want you to notice that it is slightly different than the ratio problems that we saw before. Here we have binomials in our denominators, and looking at the structure of this rational expression, we're going to have to go ahead and factor this out. So for this problem, the first thing you want to do is you want to go ahead and factor. So this would give us negative 5 over, and then x squared plus x. I'm going to take out a GCF of x, which leaves me with x plus 1. And then on the right hand side, we have x plus 6. Ooh, getting getting messy. And we have x plus 1. Okay, so that is the very first step that you need to do. Next, what you're going to have to do is you're going to have to identify your excluded values. So what can my solution not be? And looking at these here, x cannot be, an excluded value is 0 and -1. So those are my two excluded values that x can't be. So after I've done that, I'm going to go ahead and I am going to identify the GCF. Not GCF, woo! Its cousin. Identify the LCD. That's what you want. So again, in order to find your LCD, you need your shared factors, which is x plus 1. So I have x plus 1, that's a shared factor. And then you also need your remaining factors, which is just x. Okay, so here our LCD is x times x plus 1. And I prefer it in this format as opposed to this format, and you'll see why here in a moment. But third, what you want to go ahead and do is you are going to multiply by that LCD. So I'm going to multiply by this LCD. So I'm going to take my x times x plus 1, and I'm going to go ahead and multiply that times this guy. And what you do to one side, that is right, you have to do to the other. Okay, so when I multiply each term by my LCD, and again, what you hope happens is this x is going to cancel this x plus 1, cancel this x plus 1, boom. And now all I have left is -5. Pretty sweet. On this side, x plus 1, going to cancel this x plus 1, and we get is equal to x. And I'm just going to, well, I'll take 2 steps. 2-step. Okay, so now what we're going to do is we are going to solve. So I'm going to distribute here. X times x gives me x squared. X times 6 gives me a positive 6x. And this is all equal to -5. Now I'm going to add 5 to both sides to give us x squared plus 6x plus 5 is equal to 0. And remember, if I want to go ahead and solve here, all you have to do is factor this trinomial, which if we're using our AC method, it's x plus 5, x plus 1 equal to 0. And therefore, we have two solutions. X plus 1 is equal to 0. X plus 5 is equal to 0, which gives us x is equal to -1, or x is equal to -5. Okay, so these are our possible solutions. And I say possible because we need to go back and we have to check our excluded values. Okay, and when we do this, -1 and -5, coming back up here, oh, check it out. -1, sorry, -1, you can't come along. You do bad things to our equation. You divide by 0, and that's no bueno. So for that, we cross that out, right? And then this is our final solution here. X is equal to -5. Hope you like that example. Give me a thumbs up, subscribe, and check out example 4 video. Hello and welcome to this video on solving rational equations algebraically. This is the fourth video out of 4. Finally, we have arrived on how to solve rational equations algebraically. So again, noticing just similar to example 3, what we're going to have to do in order to solve this equation is factor the denominator. We need to go ahead and factor our denominator. So here we have 56 over, and looking at this trinomial, what factors of negative 15 will produce a negative 2, and that is x minus 5, x plus 3, and over here we have 7 over x minus 5. Okay, so I have factored my denominator, and then just looking, I'm gonna start to think, okay, what are our excluded values? What values can we not have as solutions? And that is 5, and here negative 3. So we cannot include those two values as solutions. Okay, so what we're going to do next is we are going to identify our lowest common denominator, and in doing so I'm going to look for shared factors, and that is x minus 5. That's shared, so I'm only going to take 1, and then I'm also going to look for any that are remaining, and that would just be x plus 3. So very, very straightforward and simple. So our LCD is, and I'll write this in blue, x minus 5 and x plus 3. Okay, so now what we're going to do is we are going to take our algebraic equation, or sorry, our rational equation. I don't know if you can hear these drums. These drums are distracting me. 56 over x minus 5 and x plus 3 equals 7 over x minus 5. And what we're going to do now is we are going to go ahead and multiply by the LCD. So I'm going to multiply by x minus 5, x plus 3, x minus 5, x plus 3. So x plus 3 cancels out, x minus 5 cancels out. Over here, x minus 5 cancels out, and we are left with 56 is equal to 7 times x plus 3, which gives us 56 is equal to 7x plus 21. And solving for x, notice this is linear, so I don't have to factor. If I had a quadratic, I would have to do the trinomial like I did in the last example. But here I'm just going to subtract 21 from each side, which gives us 35 is equal to 7x. I'm going to solve for x, dividing both sides by 7, and we get x is equal to 5. Okay, so this is our lone solution, and I'm going to go ahead and again say possible. It's possible because I have to go check my excluded values, and lo and behold, check it out. There's 5. Sorry, 5. You can't come along. You're excluded. So what ends up happening is our solution is the empty set. No solution. No solution for this example. So that is a possibility. Again, hope you liked my video. Give me a thumbs up. Please give me a thumbs up. Subscribe. Catch you next time. Bye.